Today I'm going to start a new video tutorial set regarding advanced algorithms. Under that I'm going to discuss about graph algorithms. Let's see the content. The content will be graph coloring, chromatic number, how to create an adjacency matrix, number of triangles in a graph, edge coloring, face coloring, and application of graph coloring. Now first, let's focus on graph coloring. This is also known as vertex coloring. Here, when a color is assigned to one vertex, the adjacent vertices should have different colors. So, now I am going to show you how graph coloring works by using an example. This is the example which I am going to discuss. As the first step, here we have to select an order for the vertices, and also we should have a set of colors as well. We apply colors for each vertex, and as I mentioned previously, make sure that no adjacent vertices are in same color. So here I am going to start from number 1 vertex. I will apply red color to number 1. Okay. So we can use this same color, which is red, to all the other vertices which are not adjacent to 1. Let's move to the number 2. Here you can see number 2 vertex is adjacent to number 1 vertex. So we cannot apply red color here. But see, number 3 vertex is not connected with number 1. It means it is not adjacent to number 1. So we can apply red color to number 3 vertex. Now let's move to number 2 again. Here we can apply another new color. I will apply blue color to this second vertex. Now see, number 4 is adjacent with number 2. So we cannot have blue color here, and also number 4 vertex is connected with number 3. So 4 cannot have red color as well. And also number 5 vertex is connected with number 2. So we cannot have blue color here. Now I am going to apply orange color to number 4 vertex. Then let's move to number 5 vertex. 5 is adjacent to number 4, so we cannot have orange color also. For number 5 vertex also, we need to have one new color. So I am going to apply green color for number 5. Now let's see the total number of colors that we apply. We have red, blue, orange and green. It means we have 4 colors. This 4 means the chromatic number. This is what I mentioned at the beginning of the lecture. From the content which I plan to do, I covered graph coloring and also finding out the chromatic number. Now let's move to adjacent matrix. Here I will show how to create an adjacent matrix, and in order to find out the number of triangles in a particular graph, first we have to create the adjacent matrix. Generally, you know that a matrix is like m into m equal, and inside this square bracket we write our numbers. Let's create an adjacent matrix to the graph which I showed previously. This should be n into n matrix. Here we have 5 vertices. 1, 2, here we have 5 rows, and this will be 5 into 5 matrix. When we focus on number 1 vertex, this number 1 do not contain any loops. Loops means a vertex reach itself. So we put 0 here. 1 to 1 cannot reach, so we put 0. For all the vertex, they do not have any loops, so diagonal will be 0. Now 1 to 2, yes, we have one edge, so we put 1 here. See, 1 to 3 we do not have any direct edges. 1 can reach 3, but they do not contain any direct edges. So 1 to 3 we put 0. 1 to 4. 1 do not contain any direct edge to number 4 vertex. So 1 to 4 is 0. Then 1 to 5 we have one edge, 1. Then 2 to 1, yes, 2 can reach number 1. Then 2 to 2, 2 do not contain any loops, so it's 0. 2 to 3, 2 can reach 3, 1 here. 2 to 4, yes, 2 can reach 4. 2 to 5, yes, 2 can directly reach 5. We have one edge from 2 to 5. Then 3 to 1, we do not have an edge, put 0. Then 3 to 2, we have one edge. Then 3 to 3, it's already 0. 3 to 4, yes, one edge is there. Then 3 to 5, yes, 3 can reach 5. 4 to 1, we do not have any direct edge from 4 to 1, so we put 0 here. 4 to 2, yes, we have. 4 to 3, 4 can reach 3, we have one edge. 4 to 4, 0. 4 to 5, we have one edge. 5 to 1, we have one edge. 5 to 2, yes, 5 can reach 2. 5 to 3, yes, 5 can reach 3 as well. 5 to 4, yes, we have 1. 5 to 5, it's 0. Output matrix which came is the adjacent matrix. So now, as I mentioned previously, let's see how to find out the number of triangles in this graph. For that, here we have to have the adjacent matrix and we need to have the power of 3 of this adjacent matrix. With the use of an adjacent multiplier, I am going to find out the power of 3 of this adjacent matrix. I am going to call this adjacent matrix as capital M. This is the matrix M, and here you can see the cube of matrix M. In order to find the number of triangles, the equation will be, we have to take the sum of all the values in the diagonal of M cube, and it need to be divided from 6. According to the graph, so look, here is the graph which we are going to find out the number of triangles. We have to take the sum of the diagonal values. Diagonal values are 2, 8, 6, 6 and 8. The summation of these values is 30 and it need to be divided by 6. So the answer is 5. It means we have 5 triangles inside this graph. Now let's see how to find out the global clustering coefficient of this graph. We can make a simple equation. Global clustering coefficient or C equal 3 into number of triangles divided by number of closed triples plus number of open triples. So we can say that one triangle equal 3 triplets. Okay. Or we can find out all the closed and open triples in this graph. Let's find out all the closed triples. 5, 2, 4. It is one closed triple. 5, 1, 2. Then 5, 3, 4. 5, 2, 3. And then 1, 2, 5. Then from the vertex 2 we have 2, 5, 4. Then 2, 4, 3. 2, 5, 3. 2, 5, 1. Then we have 3, 4, 2. 3, 5, 4. 3, 5, 2. Then we have 4, 3, 5. 4, 2, 5, 4, 3, 2. These are all the closed triples we have in this graph. Now let's find out open triples. We have 1, 2, 3, which is not closed triplet. Then we have 1, 5, 4. 1, 5, 4, which is also open one. Then 1, 2, 4. Also we have 1, 5, 3. Let's count how many number of closed triples we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 closed triples. Total number is 15. So as I mentioned here we have 5 number of triangles. As you can remember, here we got the number of triangles as 5. So here we say one triangle equal 3 triplets. So 5 into 3, we have 15 triplets. It means we have 15 closed triplets. Here we have 4 open triplets. Now let's put our findings to the given equation. C, or the global clustering coefficient, equal 3 into number of triangles equals 5. Then it need to be divided from number of closed triplets 5 plus number of open triples 4. Then 15 divided by 90 will be our final answer. It means C equal 15 divided by 90. This is how we find out the global clustering coefficient of the given graph. Let's see how to do face coloring of a graph. We do face coloring in planar graphs. If a graph is drawn in the plane with no crossing edges, it is called a planar graph. Here in face coloring, we assign a color to each edge and we want to make sure that no two adjacent edges are sharing the same color. This is the sample graph that I am going to describe. Let's see whether our graph is a planar graph or not. Let's redraw this graph as a planar graph. So according to our example, we have to redraw the edge from 5 to 3 because it is crossing other edges. Let's see how to do this. I will remove the edge from 5 to 3. Now let's redraw the line from 5 to 3 without crossing the edges. So we can draw like this. Now it is a planar graph. Now let's color all the faces. Now let's color the planes of this graph. We want to remember that no two faces that share the same boundary have same color. Let's add an identification for each planes. This will be plane A, B, C, D and E. Now let's see how to color. I will apply yellow color for plane A, and if we move to plane B, we cannot apply this same color yellow to plane B because it's sharing the boundary 5 to 2. And also we cannot apply yellow color to plane E as well. Now let's move to plane C. We can apply yellow color to plane C because it is not sharing any edge or any boundary. Okay. Now let's get another new color. Now I'm going to apply green color to plane B. Now see, we cannot apply green color to plane D because it is sharing the boundary 5 to 4. We can apply green color to the plane E because it is not connected with B. We want to have another new color to apply plane D, so I will apply blue color to plane D. Here we used three colors, yellow, green and blue. The minimum number of colors we have to use. This is how we do in face coloring. From this part, let's discuss about edge coloring. Let's see what is edge coloring. Here we color the edges of a graph, and also we need to make sure that no adjacent edges are in same color. I will show you with an example. For the graph 1, to the edge A to B, I will apply red color. Edge A to C, let's apply color yellow. And BCH, let's apply green. We cannot have same colors for two adjacent edges. Because of that, for this graph, we have to use three different colors. So, the minimum number of colors that we used is equal to 3. Now, let's move to the second graph. Here, to the edge AB, I will apply purple color. Then let's see, other than AB, for what edges we can apply the same color purple. We cannot apply purple for BD because it is adjacent with AB. We can apply the same color for CDH because they are not adjacent with AB. Also, we cannot apply purple color for AC as well. Now, let's apply green color for AC. We can apply same color green for the edge BD as well. They are not adjacent. So, the minimum colors that we used for edge coloring for the second graph are 2. We used only purple and green color. This is all about edge coloring. Now let's move to how this graph coloring is used in real world. Now the last part of our lecture, application of graph coloring. We can apply this graph coloring for scheduling exams, coloring district map, and also coloring maps. This is all about graph coloring. Thank you for watching and have a nice day.